The largest planet in our solar system, Jupiter, has one of the most unpredictable climates. Beautiful photos of Jupiter reveal the planet to be covered entirely with striped, turbulent clouds. In actuality, storms are all over this planet. Some are only tiny, while others are enormous and could completely cover all of Earth. But the band's depth was unknown for a very long time. Recent research revealed that the stripes extended to a depth of 3,000 kilometers, which was remarkably deep. Additional research has shown that Jupiter is suffering devastating consequences, and we are essentially clueless about why or what is actually happening. Jupiter is a mysterious planet that resists disclosing its secrets, which is why scientists have dedicated their time to discover what is actually going on. Why does the fluid inside it act as a solid body beneath the flows? Will Jupiter's massive storm ever subside? Will humans ever be able to thrive on this planet? Let's find out. By far the largest planet in the solar system, Jupiter is more than twice as massive as all the other planets put together. Jupiter is the fifth planet from our Sun. The swirls and stripes of Jupiter are actually ammonia and water clouds floating in a hydrogen and helium atmosphere. Numerous moons orbit around Jupiter. Jupiter also has a number of rings, although they are much fainter and composed of dust rather than ice, unlike the well-known rings of Saturn. Jupiter has a radius that is 69,911 kilometers. That's 43,440.7 miles wider than Earth. Jupiter would be roughly the size of a basketball if Earth was the size of a nickel. Jupiter is 5.2 astronomical units AU from the Sun, at an average distance of 484 million miles. That's 778 million kilometers. Sunlight travels from the Sun to Jupiter at this distance in 43 minutes. The solar system's shortest day is observed on Jupiter. The time it takes for Jupiter to rotate or spin once is just about 10 hours, and Jupiter completes one orbit of the Sun a year in Jovian time in around 12 Earth years, 4,333 Earth days. Only a 3-degree tilt is present between its equator and its orbital path around the Sun. As a result, Jupiter has a nearly upright rotation and less dramatic seasonal variations than other planets. Jupiter resembles a tiny solar system with its several smaller moons and 4 giant moons. Io, Europa, Ganymede, and Callisto are Jupiter's 4 largest moons and are among our solar system's most fascinating places to visit. The solar system's most volcanically active body is Io. The largest moon in the solar system is Ganymede, even bigger than the planet Mercury. Little present surface activity is indicated by Callisto's few tiny craters. Under Europa's icy surface may lay a liquid water ocean with the necessary elements for life, making it an alluring location to study. Gravity drew spinning gas and dust to form Jupiter, a gas giant, when the rest of the solar system was forming some 4.5 billion years ago. The majority of the mass left over after the Sun formed was taken up by Jupiter, which now contains more than twice as much material as the other worlds put together in the solar system. By now, it's no news that Jupiter is a gas giant, hence it lacks a true surface. Mostly gases and liquids are flowing around the planet. The surface of Jupiter resembles a patchwork of vibrant cloud bands and patches. The skies of the gas planet likely consist of 3 separate cloud layers that collectively measure roughly 44 miles or 71 kilometers. The bright hues you see throughout Jupiter may be plumes of gases, including sulfur and phosphorus, rising from the planet's heated center. Jupiter's spots can last for a very long time since there is no solid surface to slow them down. At the equator, some of the prevailing winds on stormy Jupiter can reach speeds of up to 335 miles per hour or 539 kilometers per hour. The Great Red Spot, the largest storm in Jupiter's atmosphere that has been raging in a counterclockwise swirl for more than a century, is quite well known for its intense storms. The fabled storm is so large that it may engulf the entire planet. Astronomers have just learned that the storm extends farther into space than they had previously thought. Scientists discovered that Jupiter's storms go deep beneath its clouds and provide a clear view of the cloud interiors based on data from the Juno spacecraft. The greatest storm in the solar system, the Great Red Spot, is a high-pressure anticyclonic cyclone. More than 400 miles per hour is the counterclockwise rotational speed of the storm's clouds. Compared to Earth, a Category 4 hurricane's maximum wind speed is only 150 miles per hour. Imagine the destructive power the Great Red Spot possesses. In addition to that, several storms are present in Jupiter's atmosphere. In actuality, storms practically blanket the entire world. On the gas giant's planet, where there is no surface and the planet's internal heat mostly influences the weather, storms frequently linger for a long time. However, scientists have long held that Jupiter's storms are limited to the depths of the planet where sunlight can reach and where water is still able to condense. However, a recent study contradicted that. The researchers behind the new study examined the vertical structure of the Great Red Spot as well as 2 other storms on Jupiter, using information from NASA's Juno mission. Juno has been orbiting Jupiter every 53 days since it reached Jupiter's orbit in July 2016. The spacecraft looks under Jupiter's cloud tops using a variety of onboard instruments. The storms stretch below the level at which water condenses and clouds form, according to the data from Juno's microwave radiometer, which can see hundreds of miles deep inside the planet. While some of the storms, like the Great Red Spot, reach depths of 60 miles below the cloud tops, others reach depths of almost 200 miles. However, the surrounding jets that fuel the storm travel even further into the planet's atmosphere than the Great Red Spot itself. The Great Red Spot penetrates Jupiter's atmosphere for around 500 kilometers, but the surrounding jets are located at a depth of over 3,000 kilometers. On Earth, storm development is greatly influenced by water and sunlight, but it doesn't seem to be the case on Jupiter. These routes go down deeper and pass right through the water cloud like it doesn't even matter. Scott Bolton, principal investigator of Juno from the Southwest Research Institute in San Antonio, said. And so how that works is going to require new modes and new ideas to explain. This suggests that there might be a link between the deep atmosphere of Jupiter and its interior. Why does it matter? Scientists are closely examining Jupiter since it may provide the answer to the solar system's creation tale. Its size is a key factor in being considered too. The size is one of the key reasons that it's really of high interest to us because it's so large and massive that it is thought to have formed first, Bolton said. So when we study Jupiter, we're taking a look at the very early part of the solar system. How did planets form? Where did we come from? How is our solar system made in general? The diagram of the solar system is widely recognized. The orbital trajectories of the planets around the Sun are indicated by visible circles. The truth is somewhat different. Because the star is so big, the gravitational center of the planets usually lies deep inside the Sun. Jupiter, however, is an enormous body in and of itself and has no connections to this solar point. Jupiter's mass is 2.5 times that of other planets put together, just to give you an idea of how big this planet is. Instead of being inside the star, the gravitational center between the Sun and Jupiter is above it. Surprisingly, the Earth and the Sun both revolve around this center. The Sun, which is still the largest object in the solar system, is so close to this gravitational point that it almost doesn't seem to affect the star. On the other hand, Jupiter is a dwarf relative to the Sun and is also some distance from the Sun, putting it in conspicuous orbit. On the other hand, the Great Red Spot is akin to Jupiter's storm's paternal grandfather. It has been roving for a very long time, but we've recently seen a decrease in size. Does that imply that it will eventually vanish? Jupiter appears to be a massive striped ball that spins quickly. The clouds with light-colored stripes have rising air, whereas the clouds with dark-colored stripes have sinking air. On Jupiter, the contrasting pale and dark stripes are caused by winds that are moving in different directions. When this occurs, they have the ability to create large cyclones, much as how pushing and dragging a beach ball will cause it to spin. Humans have observed the Great Red Spot for at least 200 years and has been blowing powerful winds for practically the whole time. It can alter from day to day, just like any storm. It sometimes resembles a circle, other times an egg. Additionally, its color sometimes shifts from brownish red to pale red. It occasionally seems virtually white. But recently, researchers have found that the massive cyclone is getting smaller. The Great Red Spot was nearly 3 times bigger than it is now about 100 years ago. So why is it reducing in size? It helps to first comprehend why cyclones on Earth weaken and eventually stop, in order to comprehend why it is contracting. On Earth, cyclones frequently develop over warm, deep waters before migrating to land or a colder body of water. A cyclone's winds slow down when they come into contact with the solid ground, and therefore the cyclone slows down. On Earth, cyclones are also affected by surrounding weather and winds, which can cause them to flake away in a matter of days. But unlike Earth, Jupiter doesn't have a stony, hard surface. In addition, although the air inside Jupiter's clouds is extremely cold, the air outside is extremely hot. Storms have enough energy to rampage for months or even years because of this warm air. The Great Red Storm can, therefore, actually grow a little bit taller as it does so, despite the fact that it is shrinking. It also has enough energy to continue spinning. Additionally, as it collides with nearby storms and winds, we can observe how it is flaking away at the edges. However, it is yet unclear to astronomers whether this will completely eliminate it. Some believe that it could eventually split up into numerous smaller storms. Will we ever discover the secrets of this planet and study it? What would occur if people attempted to set foot on Jupiter? Landing in a new world is the finest way to investigate it. For this reason, people have sent spacecraft to the Moon, Venus, Mars, Titan, and other places. But there are regions of the solar system that we will never fully comprehend. Jupiter is among them. Most of the gas that makes up Jupiter is hydrogen and helium. Therefore, attempting to land there would be similar to attempting to do it on a cloud on Earth. On Jupiter, there is no outer crust to cushion your fall. Nothing except an unending expanse of air. So the crucial query is, could you fall through Jupiter and emerge at the other end? You wouldn't even reach halfway, it turns out. This is what would happen if you attempt to land on the gas giant. First things first, there is no oxygen in Jupiter's atmosphere. Therefore, be careful to pack enough air for yourself. The sweltering heat is the next issue, so make sure to bring a fan. You are now prepared to embark on an incredible quest. For scale, here's how many Earths you could stack from Jupiter's center. As you enter the top of the atmosphere, you'd be traveling at 110,000 miles per hour under the pull of Jupiter's gravity. But prepare yourself. The denser atmosphere below will hit you like a wall when you soon enter it, but it won't be enough to dissuade you. You will arrive 155 miles below the cloud tops in around 3 minutes. You will feel the full force of Jupiter's rotation here. The planet with the quickest rotation in our solar system is Jupiter. One day, as we mentioned previously, lasts roughly 10 Earth hours. This generates strong winds that can travel at speeds of more than 300 miles per hour throughout the globe. You get to the uppermost point that humans can travel to, around 75 miles below the clouds. The Galileo probe made it this far when it dove into Jupiter's atmosphere in 1995. It only lasted for 58 minutes before losing touch and then collapsing under intense pressure. Nearly 100 times as much pressure as at Earth's surface exists down here. Additionally, you won't be able to see anything, forcing you to rely solely on tools to get a sense of your environment. By 430 miles down, the pressure is 1,150 times higher. If you were in a spaceship designed like the Trieste submarine, the deepest diving submarine on Earth, you might be able to survive down here. A spacecraft won't be able to survive any deeper because of the pressure and temperature. Let's assume that you might discover a means to go much lower. Some of Jupiter's greatest mysteries will be revealed by you. Sadly, you won't be able to inform anyone. You won't be able to converse, since Jupiter's dense atmosphere absorbs radio transmissions, cutting you off from the outer world. Once you've reached 2,500 miles down, the temperature is 6,100 degrees Fahrenheit. The metal with the highest melting point in the universe, tungsten, can melt at temperatures that high. You will have been falling for at least 12 hours at this point. You won't even have reached the halfway point. At 13,000 miles down, you'd reach Jupiter's innermost layer. The pressure is 2 million times greater here than at the surface of the Earth. Furthermore, it is hotter than the Sun's surface. These circumstances are so severe that they alter the hydrogen's composition everywhere around you. Hydrogen molecules are squeezed so closely together that their electrons dislodge, resulting in the formation of metallic hydrogen, an uncommon material. Hydrogen in metallic form is very reflective, so it would be hard for you to use lights to look down. And it has the density of a rock. Therefore, when you descend further, gravity's downward pull is resisted by the buoyant force of the metallic hydrogen. Like a yo-yo, gravity will eventually draw you back down once that buoyancy has shot you back up. You will be stuck in mid-Jupiter free floating, unable to move up or down, and with no way out when the two forces equalize. To sum things up, it would be foolish to attempt to land on Jupiter. Who knows what lies beneath those magnificent clouds? However, we may still observe and awe at this enigmatic world from a distance till our technology becomes way more advanced. Well, that's hoping any advanced technology can even help overcome the gas giant's defenses. Unlike Earth, the planet Jupiter has more than one moon. In fact, Jupiter has at least 79 different moons, and Europa is just one of them. Europa is the 6th largest moon in the Jovian system and is about 90% the size of our own moon that orbits Earth. Recently, the Hubble Space Telescope made a discovery that shocked and excited NASA. After years of suspicion and speculation, Hubble detected water vapor in the atmosphere of Europa. This massive discovery gives scientists a much better understanding of Jupiter's moons and offers the idea that maybe, just maybe, Europa has conditions that are hospitable for life. If that were the case, it means that future scientific missions related to the Jovian system will have a strong focus on finding life. Like all things related to scientific space discoveries, this huge find raises even more questions than answers. Observations of water on Europa have been made before, but all previous discoveries of water on the Moon have been associated with plumes of water erupting through the ice that coats the planet. These plumes of water are similar to geysers found on Earth, although the plumes are thought to shoot about 60 miles into the sky. However, these new findings show amounts of water vapor spread over a larger area of Europa. All said and done, the vapor has been spotted many times over the last 2 decades, which suggests a long-term presence in Europa's atmosphere. Why is this so shocking? Well, it's not just because finding water in any part of the solar system is cause for celebration. The Europa finding is even more surprising because the moon is so darn cold. The daytime high on Europa is about -260 degrees. That's partly because the moon reflects sunlight off of itself, preventing it from warming up much. Yet the moon is still producing a persistent amount of water vapor, something that is making scientists wonder what other tricks Europa has up its sleeve. Images of Europa from satellites have been captured several times. In fact, Europa is quite popular among scientists and astronomers. In the 1970s, NASA's twin Pioneer and twin Voyager spacecraft provided the first close-up pictures of a damaged frozen surface. The Galileo mission, which took place from 1995 and 2003, provided much more information on Jupiter and its moons. In addition to the Hubble Space Telescope and other observatories located near or on Earth, several spacecraft have gone past Europa as they made their way to other destinations. However, these views are constrained since they have all been on or near the ecliptic, a plane on which the Sun, planets and many of the moons of the solar system circle. Now you can see why such incredible photographs of Europa and its water vapors are so special. For years, it had all been hiding in plain sight, just waiting for NASA and scientists on Earth to discover it. This incredible find was made by Lorenz Roth of the KTH Royal Institute of Technology, Space and Plasma Physics in Sweden. Roth made his discovery by examining data collected by the Hubble telescope over multiple years. He did so by using the Telescope Imaging Spectrograph, or STIS, which allows astronomers to assess the chemical elements that make up a planet or moon's atmosphere. Roth was able to quantify the amount of molecular oxygen in Europa's atmosphere based on these measurements. While that might not sound like very exciting work for you and me, it allowed Roth to stumble upon this incredible discovery. While finding water vapors on Europa is without a doubt a major deal, it's not the first time that one of Jupiter's many moons revealed its affinity for liquid. Just months ago, it was confirmed that water vapors also exist on another of Jupiter's moons, Ganymede. Located 500 million miles from the Sun, the water on Ganymede is frozen solid in temperatures that reach as low as -300 degrees Fahrenheit or -184 degrees Celsius. It's long been assumed that if an ocean exists on Ganymede, it would have to reside some 100 miles below the surface due to its frigid climate. Despite the bone-chilling temperature, it was determined that when the charged particles from the Sun reach the Moon, it's enough to turn the ice into water vapors. Still, the news of water on Europa is a bit more surprising, simply because Europa's surface is generally more consistently cold and rarely ever peaking above -260 degrees Fahrenheit. Finding water vapors on the Moon means that Europa immediately shoots to the top of the list for places that scientists want to explore. And in just a few years, those startling revelations may come to pass. That's because Europa and the other moons surrounding Jupiter are set to be explored within a decade. The ESA's Jupiter Icy Moons Explorer, otherwise known as JUICE, is set to launch in 2022 and will arrive in the Jovian system in 2031. JUICE is a major project that is being created to really understand Jupiter's entire system so much better. The centerpiece of JUICE will be a powerful probe that will carry instruments comprising of the most powerful sensing equipment ever created. It will fly to Europa and many of the other moons and catalogue what it finds. Specifically, JUICE is looking for any more signs that life could have existed or still does. For years, not much has been known about Jupiter as it existed far past our reach in the icy depths of space. But these latest discoveries on the planet's moons have shown that this is a section of the solar system that we should be paying close attention to. Soon enough, we will get more answers. But until then, we will have to keep hoping that once we do finally explore Europa, it will be worth the wait. Neptune, the 8th and farthest planet from the Sun, is a gorgeous blue sphere named after the Roman sea god Neptune. Pluto once held this distinction, however, the International Astronomical Union downgraded Pluto of its status as a planet. Neptune, which is over 3 billion miles from the Sun, orbits the Sun once every 165 years. Thus, it hasn't quite completed a full cycle around the Sun since it was discovered. Known as a gas giant, Neptune is one of 4 planets outside the asteroid belt that fall under this category, Jupiter, Saturn, and Uranus included. These planets have a diameter of 4 to 12 times that of Earth. They have no solid surfaces but vast atmospheres containing significant volumes of hydrogen and helium, as well as traces of other gases. Neptune is the smallest gas giant in our solar system, with an equatorial diameter of 30,775 miles. That's not to mention the fact that it can house roughly 60 Earths in volume. Neptune is the only large planet that requires a telescope to see. 1/5 as bright as the faintest stars visible to the unaided eye, it has the apparent magnitude of 7.8. As a result, it is safe to assume that Neptune had never been observed before the invention of telescopes. Over the last few years, Earth-based telescopic studies of Neptune have revealed intriguing hints of dynamic cloud structures on the faraway planet, allowing scientists to estimate the speed of the planet's rotating winds. In this context, Voyager's scientists prepared for the first encounter with Neptune, possibly the only close-up look at Neptune many of us would ever get. NASA's Voyager 2 became the first spacecraft to see Neptune, its last planetary target, in the summer of 1989. Voyager 2 made its closest approach to any planet since leaving Earth 12 years ago, passing nearly 3,000 miles above Neptune's North Pole. Voyager 2 passed around 25,000 miles from Neptune's largest moon, Triton, 5 hours later. Scholars and scientists alike were obliged to re-evaluate their understanding of the solar system's other large planets as a result of what they discovered. The planet's blue tint, caused by the abundance of methane in the atmosphere, is the most noticeable feature in Voyager images. The longer wavelengths of sunlight are more easily absorbed by methane. Colors on the blue end of the spectrum are the only ones left to be reflected. Even though Neptune receives only 1/3 of the amount of sunlight as Jupiter, it is nonetheless a lively planet. Jupiter's hurricane-like storms can be seen as several big dark blotches on the surface. The largest of these spots is enough to contain the entire Earth. The storm's size was estimated at 8,000 by 4,100 miles, making it similar to Jupiter's red spot. Originally, it was speculated to be a vortex. In 1989, the Voyager 2 spacecraft captured a shot of Neptune's massive anticyclonic storm. The feature, which the discoverers named the Great Dark Spot, looks to be an anticyclone comparable to Jupiter's Great Red Spot. The Great Dark Spot on Neptune is equivalent in size to Jupiter's Great Red Spot and is located at the same latitude. The Great Dark Spot on Neptune, on the other hand, is significantly more changeable in size and shape when compared to its cousin Jupiter. The bright, wispy cirrus-type clouds that cover the Great Dark Spot's southern and northeastern edges could be akin to the lenticular clouds that occur above Earth's mountains. A brilliant, irregularly shaped eastward-moving cloud orbits Neptune at around 42 degrees south, more quicker than the Great Dark Spot, scooting about Neptune in roughly 16 hours. It's possible that this scooter is a cloud plume ascending between cloud decks. Voyager's scientists have designated a second region, known as D2, 55 degrees south of the Great Dark Spot. The heat radiated by Neptune's atmosphere was also measured by Voyager. Above the clouds, the atmosphere is hotter at the equator, cooler in the middle latitudes, and warm again near the South Pole. It's also remarkable that the polarity of Neptune's magnetic field is the same as Jupiter and Saturn's, but opposite that of Earth. In addition, Neptune's magnetic field provides further insight into the planet's structure and dynamics. The Voyager discovered auroras in Neptune's atmosphere, which are identical to Earth's northern and southern lights. Electromagnetic radiation from the Earth's magnetic field lines causes auroras on Earth. This convoluted magnetic field makes it possible for the auroras to occur over large areas of Neptune, rather than simply around the planet's magnetic poles. On Neptune, the auroral output is predicted to be around 50 million watts, compared to 100 billion watts on Earth. Unlike the other frozen satellites Voyager has explored, Triton's size sets it apart from the others. An orbit of Triton around Neptune takes 5.875 days, with an average distance of 205,000 miles above the planet's cloud tops. Triton is about 3/4 as large as the Moon on Earth, and it travels in a tilted circular retrograde orbit. Voyager 2 images show active geyser-like eruptions shooting out nitrogen gas and dark dust particles many kilometers into space, showing Triton to have a fascinating geological history. Approximately 1,680 miles across, Triton has a diameter of 2.066 grams per cubic centimeter. This suggests that Triton's interior is more rock-rich than those of Saturn's and Uranus's icy satellites. Triton's high density and retrograde orbit both point to it being a captured object, not something that formed in the vicinity of Neptune. Tidal heating may have warmed Triton in its originally eccentric orbit, and the satellite may have remained liquid for up to 1 billion years after its capture by Neptune, if this is the case. Triton's history is still a mystery, but icy volcanism is undeniably a part of it. At minus 235 degrees Celsius, Triton is the coldest place in the solar system. To comprehend what is taking place on Triton, one must first ask, what is the definition of cold? What is the definition of softness? What is the definition of youth? Water ice with a melting point of 0 degrees Celsius deforms more easily and quickly on Earth than rock. But at the extraordinarily cold temperatures observed on Triton, more than 4.5 billion kilometers from the Sun, it becomes virtually as hard as rock. Because nitrogen and methane ice are too soft to hold much of their own weight, the majority of the geologic formations on Triton's surface are most likely made of water ice. At fewer than 100 degrees above absolute zero, nitrogen and methane, which constitute a thin veneer on Triton, converts from ice to gas. The nitrogen and methane on Triton are responsible for the majority of the geologically recent eruptions at very low cryogenic temperatures. Voyager images of many geyser-like volcanic vents, which appear to be spewing nitrogen gas coated with extremely small black particles, showed evidence of such eruptions. To reach Triton's surface, the particles must first be lifted to heights of 1 to 5 miles in the air, where they are then blown downwind. For some time, scientists had hypothesized about the existence of incomplete rings or ring arcs around Neptune. Most agreed that shepherding satellites would herd ring particles between them, preventing them from either escaping into space or falling into the atmosphere of the planet. This theory explains certain novel occurrences seen in Jupiter's, Saturn's, and Uranus's rings. A ring arc-like pattern was captured by Voyager 2's cameras as it approached Neptune. A closer examination of the images revealed that the rings do indeed extend all the way around the planet thanks to enhanced resolution and computer processing. Earthbound astronomers were unable to detect the full rings because the rings are so diffuse and the material in them is so fine. It's now been determined that one Earth-based ring arc observation was caused by the transit of a tiny satellite through the ring area, according to Voyager's discoveries. Researchers were able to determine the number of rings and a tentative nomenclature late in their encounter. The surface of Neptune differs significantly from that of Earth. The surface of the planet is covered in thick clouds, but the planet's interior is filled with dense pressurized gases. Rock and ice make up the majority of the interior. One can't really tell what the prospects for Neptune and its satellites are in the future. New Horizons is a project created by NASA all the way back in the 1980s. It was put together with one purpose: to finally get a better grasp on Pluto and see how this bizarre little chunk of ice worked. The $720 million project might have been dreamed up by the brilliant minds at NASA 30 years ago, but it wasn't until the early 2000s that it was officially given approval and a launch date. New Horizons took to the stars in January 2006, given the task of the first ever flyby of Pluto. Ever since the dwarf planet was first discovered back in the 1930s, many questions have swirled around it. New Horizons would be the best chance to really understand what was going on by getting very, very close to its surface. In fact, the New Horizons vessel would pass within 7,800 miles of the frigid, rocky surface of Pluto. That would definitely be close enough to snap quite a few promising pictures. It took New Horizons nearly 10 years to reach its destination, but on July 14, 2015, it zoomed past the planet for the first time. The images that New Horizons sent back were revolutionary and truly gave a new view of this beautiful, mysterious planet. Massive ice mountains, nitrogen ice plains, and Pluto's well-known heart were all on crystal-clear display for the first time. These images were groundbreaking for many reasons, but they only told half the story of Pluto. Because of lighting issues, New Horizons was only able to grab shots of the side of Pluto that was illuminated by the sun. As you can imagine, capturing pictures of the dark side of Pluto is a complicated process. Backlighting and speed are major issues. Simply put, if New Horizons tried to get shots of Pluto's dark half, the sun would backlight the images and make them nearly impossible to comprehend. It's like when the sun is shining through your car's front windshield. You can't see much of anything. It's all blocked out by the overwhelming brightness of the sun. But the team behind the mission had a thought. Based on their research and hard work, they determined that the dwarf planet's largest moon, Charon, might reflect enough light to cast some on Pluto's surface. Charon isn't like our moon. It retains a lot more light and reflects it much more too. Even with the sun on the opposite side, it was possible that Charon could be used as a spotlight on Pluto. The idea was enough to make the team turn the vessel back towards the sun and take one last look at Pluto. To make this new photo session work, the researchers had the spacecraft snap 360 short photographs of the surface of the dwarf planet. Each photograph was just 0.4 seconds long to prevent overexposure. The team also photographed the sun without Pluto in the frame so that it could be deleted later. What they saw was well worth their time. But at first, deciphering these photos was too tall a task. It just took too much time, according to Todd Lauer of the National Optical Astronomy Observatory in Tucson. But a few years later, Lauer and his team dug into the images and made them work by using computer programs to eliminate fuzz and other visual impairments in the photographs. The images showed the strange, unique way that Pluto's atmosphere works. On the dwarf planet, seasons move very, very slowly. In fact, each season is decades long. The seasons and atmosphere are controlled by how much nitrogen is in a gas phase in the air and how much is frozen on the surface below. If more nitrogen ice evaporates, the atmosphere obviously becomes thicker. However, if there is too much frozen on the ground, the atmosphere might not function correctly and collapse altogether. New Horizons photos revealed that Pluto's south pole seemed notably darker than its north pole. That proves that despite the fact that winter was approaching, there was not a lot of new nitrogen frost freezing out of the atmosphere. Although the last summer ended decades ago, Pluto cools incredibly slowly. So maybe it's still warm enough that ice can't form, keeping the atmosphere from collapsing. These images from the blind side of Pluto gave an in-depth look at the atmosphere of the planet in ways that scientists had never had before. But there was more discovered in the photographs from New Horizons, including something that can only be summed up with two words: ice volcanoes. The idea of a volcano spewing ice might seem bizarre and truly out of this world to you, and that's because frankly it is. In fact, what was found on Pluto by New Horizons is a first for our solar system, something that literally has never been seen anywhere else. Images from the Deep Space Probe captured what looks like two volcanoes built out of frozen ice that once oozed molten ice from deep within the dwarf planet. The two peaks, named Wright Mons and Picard Mons, tower as high as 5 or 6 kilometers above the planet's surface, with rims more than 150 kilometers across. Instead of hot lava, like in Earth's volcanoes, flowing ice would spew forth from these massive mountains. Even though these are ice volcanoes, they would still need to be powered by a major internal heat source. And that's one of the strangest things about this discovery. In the past, most experts thought that Pluto was far too small to maintain that sort of heat needed to power a volcano. However, finding these ice volcanoes suggests that something has to be keeping things warm below the surface. As one researcher at NASA put it, whatever they are, they're definitely weird. These newfound volcanoes are a startling and amazing find, but they also raise many more questions about this cold alien world. After decades of thinking we had this dwarf planet figured out, the work done by New Horizons has shown that there is still so much to figure out about Pluto. From the harsh atmosphere to the bitter cold to one-of-a-kind ice volcanoes, New Horizons has revealed more than ever expected about Pluto. It's a strange small ice cube of a planet that, for the time being, is full of more questions than answers. After millions of dollars, decades of planning, and years of flying through deep space, New Horizons has illuminated the planet in some incredible ways and has left the door open for even more discoveries in the future. New NASA analysis reveals that Saturn's rings are eroding at the maximum rate predicted by decades of Voyager 1 and 2 observations. Every year, more and more material is being lost from the rings. The sun's radiation and incoming micrometeorites perturb the ring's dusty particles, causing them to become charged. The atoms convert into spheres that spiral around Saturn's magnetic field lines in a split second. Gravity drags the particles into Saturn's clouds when they are too close to the planet's apex, where they evaporate. It's called ring rain, and over time it and other events will erode the distinguishing element that distinguishes Saturn from the rest of the solar system until there is nothing left. It's a good idea to keep in mind that this will take time. According to scientists, the rings are expected to vanish in around 300 million years. The people of Earth still have plenty of time to admire and study Saturn's rings. Because while astronomers are aware that the rings are fading, they don't know everything there is to know about these bands, including how they came to be there in the first place. Saturn's rings have fascinated observers for years, but it wasn't until NASA's Voyager probe flew by in the early 1980s that we got a close look at them. A few years ago, scientists believed that Saturn's rings were likely generated around 4.6 billion years ago, when the solar system was in its infancy and tumultuous state. With rocky debris floating around everywhere back then, a new planet might have easily snagged a few, hung them around its center, and let gravity flatten them. In contrast, the flyby of Voyager showed a different scenario. When researchers analyzed their data, they discovered that the rings were not as old as previously thought, which meant that they were not billions of years old. The rings have to be substantially younger, between 10 and 100 million years old. Saturn's rings are made up of fragments of water ice ranging in size from tiny dust grains to boulders several yards or meters large. A delicate balancing act is taking place between Saturn's gravity and the ring particles' orbital velocity, both of which are trying to drag them back into the planet. Ultraviolet light from the Sun or plasma clouds from micrometeoroid assault of the rings can change tiny particles. At Saturn's rings, the planet's magnetic field bends inward toward the planet, causing particles to experience the magnetic attraction. Once charged, the balance of the forces on these tiny particles changes significantly, and Saturn's gravity draws them along the magnetic field lines into the upper atmosphere. Once there, the frozen ring particles evaporate and the water can react chemically with Saturn's ionosphere. The lifespan of electrically charged particles known as H3+ ions, which are composed of 3 protons and 2 electrons, increases as a result of these processes. As a result, scientists at the Keck Observatory on Mauna Kea, Hawaii, used infrared detectors to investigate how the H3+ ions glow when exposed to sunlight. Saturn's northern and southern hemispheres were illuminated by blazing bands where magnetic field lines that intersect the ring plane entered the planet's interior. They studied the light emitted by Saturn's ionosphere to calculate how much rain had fallen from the ring and how it had affected the atmosphere. More than 3 decades previously, scientists had estimated that the amount of rain fell in a certain region of the southern United States, which received the most of it. Saturn's ring system had previously appeared to be as old as the solar system. However, evidence now appears that the rings did not exist when dinosaurs roamed the Earth. Where would Saturn have received the basic material if the solar system had calmed down by then? Paul Estrada, a NASA research scientist who has examined Saturn's rings, remarks that the probability of an event forming the rings now, in astronomer language meaning within 100 million years or so, is very unlikely. Further evidence for this hypothesis comes from more recent observations. NASA's Cassini probe studied Saturn's rings in 2017 before being annihilated by the planet's atmosphere. According to the mission's final measurements, the rings were not big enough to be old, as had been suspected by the Voyager missions. The formation of Saturn's rings is still a subject of debate among scientists. However, if the rings are genuinely young in cosmic terms, scientists believe they developed when one of Saturn's older moons came too near and was smashed to pieces. A small moon, like our own, may have been exploited to create thousands of Saturn-like ring systems. The narrative of Saturn's rings serves as a reminder that our solar system's worlds, however still and static they appear from here, are active places with their own dramatic histories. When compared to the world we live in, where everything is a mess and constantly changing, we imagine the universe as a crystal that never changes. At first glance, Saturn's rings appear to be a ledge you could swing your legs over as if they were solid. They, on the other hand, are not. There is a lot of movement going on in those particles, and they are knocking into one another. Tiny moons have left their wakes behind, and scientists were able to gauge the rate at which ring material was being sucked into the planet. However, with Cassini, astronomers will be able to examine the process more thoroughly and make the most accurate predictions yet about how long Saturn's rings will remain. After Saturn's rings have gone, the universe may perhaps reward the planet with a fresh set of rings. A mechanism similar to the last one may exist, whereby a moon is broken apart, a comet comes in too close, and the cycle restarts from the beginning. Perhaps this won't be the last time we glimpse Saturn's rings. But the gaseous giant's ring isn't the only thing it's losing. At the same time that Saturn's distinctive rings are disappearing, its largest moon is also in danger of disappearing. Distancing ourselves from others may be the new normal on Earth. With Saturn's largest moon, Titan, racing away from its parent planet at a rate of 100 times faster than previously anticipated in outer space, it has taken on a whole new significance. Saturn's gravity may not be powerful enough to maintain Titan, but it is strong enough to obliterate Titan's rings in another 100 million years. How ironic is that? There is a slight gravitational attraction exerted by moons on the planets they orbit. This gravitational interaction causes tidal waves in the waters on Earth. Our planet's gravitational field changes as a result of the friction caused by this tugging. The Moon moves away from us at about 1.5 inches, that's 3.8 centimeters per year. In a similar way, Titan pulls on Saturn, but Saturn's friction is assumed to be weaker than on Earth due to the gaseous composition of the planet, as opposed to Earth's rocky one. Recent calculations imply the Moon is moving away from Saturn at a rate of only 0.04 inches, that's 0.1 centimeters per year. Saturn's largest moon was created very near to the planet, but over 4.5 billion years, it has migrated out to where it now orbits, about 746,000 miles, that's 1.2 million kilometers, from the planet. The majority of previous research suggested that moons like Titan and Jupiter's moon Callisto developed at a similar orbital distance to where we observe them presently. This suggests that the Saturnian moon system and its rings developed and evolved more dynamically than previously thought. Neither the Earth nor its moon is faultless. In fact, our moon, like every other child-parent relationship, moves away from its parent planet at a rate of about 3.8 centimeters per year. Tides, even the occasional werewolf urban legend, are caused by the moon's gravity on Earth. As a result of the friction, the Earth's own gravitational field is distorted, dragging the moon back into its orbit. You'd think that would keep the moon in check. The entire process, though, is what gives the moon additional energy to travel farther away. Saturn's gravitational force, on the other hand, is considerably weaker than that of Earth. Since it's formed of gas, not rock, it seems logical. Titan is unique in the solar system since it is the only moon with an atmosphere. It's covered in liquid hydrocarbon rivers and seas such as methane and ethane. Scientists believe there may be a liquid water ocean behind the thick covering of ice capable of supporting life. However, if Saturn's moon continues to move away from the planet, it would limit our ability to examine it thoroughly. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen for more mind-blowing videos about space.